Here we go. Methods in Java. I'm really curious how the emotions are going to be thinking back to when we learned functions in Python. Is it more of crying as we think about the parameter passing, sending over parameters, returning values for functions? Does that more so elicit this type of a reaction from you? Or is it, no, they're not that bad at all? Let us find out. Here we go. Let me open up this, turn on the pointer. Let's go. Python functions versus Java methods. In fact, Python has both functions and methods. What is a function? As we know, a function is a block of code, I say here organized, reusable code, that basically performs some specific task. A typical Python function or program will have a main function, and you'll likely have many other supporting functions that just help with the functionality of your program. Python also has methods. What are methods in Python? A method is a function that belongs to a particular object, right? Let's think about that. We have string objects in Python, and then if you make a new string, you have methods that you can use to operate on that particular string. So those are methods. They both are effectively a reusable block of organized code that performs a specific or particular task. The difference in Python is that methods are inherently connected to specific objects, such as string methods for string objects. Java only has methods, and this is because everything in Java is coded within a class. So what is a method in Java? Same thing. A method is a reusable block of organized code that performs a specific task. And just like Python and Java, a standard program is going to have a main method, and we'll have many other methods that will be there to support the functionality of our program. So a naive explanation is simply to say, hey, Python functions and methods, we'll think of them as analogous to a Java method. There's certainly more to it than that, and we'll be discussing more and the nuances and the how we can understand the distinctions between a Java method versus a Python function or method. And we'll get to that later. But for now, it's good enough to just think of, what I remember of Python functions, that's going to be Java methods. So let's start by examining a very basic Python function, a super easy one that is so easy. But the value there is that if we can remember our Python and understand how functions work with this very easy method and really understand the anatomy of this Python function, that will help us when we're trying to therefore understand subsequently the Java methods for this exact same function. So here we have this custom-built max function. Of course, we know in Python, we already have a max built in. Even in Java, we have a built-in max function or math method as well, but we're going to make our own max function. This function receives two parameters, and it simply determines which of those two numbers is maximum, and it returns that maximum value. So here's the Python code. We're going right to the code. Notice we have a max function defined at the top. We have a main function immediately underneath, where inside the main function, we're asking the user to enter two integers. We're saving those two integers into the variables a and b. And then on line 12, we invoke the max function. We call this max function that we made, and we send to it those two values. We send to it a and b. So the two values we read from the user, we call this max function because this is an assignment. With the assignment operation, we know that we should look on the right side. We see the max function, AB, so we send A up to num1. We take B, we send B up to num2. We perform the logic within this if block. If num1 is greater than num2, we're going to return num1, else we return num2, and that gets saved into the max number, and then we print. So let's go look at a detailed running of this within Thani. As you've heard me talk about Thani in the past, it is a great educational IDE. It's a horrible IDE from a professional perspective, but from an educational perspective, It's wonderful. And one of the main positives is its debugger. So the debugging, it really just highlights every step, and it's gorgeous. So I'm going to run the debugger on this, and let's see how the Python interpreter analyzes this code. So the first thing is the interpreter sees, oh, I have this max function. Cool. You have a main function. Cool. That's all it does. It's just recognizing that you have these two functions. You know what? Let me start over and turn on view variables. Now let's do this again. Debug. Once again, you got a max function, cool. You got a main function, cool. And it kind of saves them, at least this IDE Thani is suggesting it's saving it as a variable. It's not as a variable, but it's just putting it here. It's basically recognizing you got this thing defined as max, got you. Maybe we'll use that, maybe we won't. You got this thing called main, got you. Line 15, we call main. Well, look what happens. When we call main, here's main, and main pops up in its own window because it's a function. So here's main, its own window with local variables. And what happens? Let's keep stepping through this. We have to read in from the user a value A. Let me move this up so you can see me type that in. Let's type in the value 7. So 7 is read in as a string. That's why you see that pair of single quotation marks. It's read in as a string. We use the int function to integerize it, to convert it to an integer, to cast it to an integer. Now it's 7, and A has the value 7 right here. It's a local variable. It's not over here in my main program. It's only the scope of this is defined. It's within this function, as we know from Python. So A is understood right here as part of this main function. Let's keep going. We come to B. We're going to enter an integer. Let's enter, how about 5? Enter. We read in the string 5. We're going to keep stepping into, and now we get B has the value 5. It's a local variable. Now look at this line of code. The max number equals max AB. This is an assignment. So the Python interpreter is going to look on the right side. I hit F7 to step in. I'm going to do that again. What's going to happen? We're going to send over the value 7 is A. B has the value 5, as we see right here. And now we're going to call the max function, and we're going to send over 7 and 5. And check this out. When I do that, this window opens up. And we have the max function, and you can see here it says in the upper left, max of 7, 5. And notice already we have two local variables because that 7 was sent over and it was saved inside num1. That 5 was sent over, it was saved inside num2. So now we have these two local variables, num1 and num2. If num1 is greater than num2, let's go through the code. If 7 is greater than 5, that's true. So we're going to return 7. And where does 7 get returned? When I hit the next button, this window is going to close because this function, it's done. 7 returns, and where does it get saved? It gets saved into this variable, the max number. So now we have a new variable, the max number is 7, and then I print out the max of blank and blank of 7 and 5 is the max number, which is 7, and we print the result. Absolutely wonderful educational IDE. So that's a reminder, a thorough reminder of how a basic function works in Python. And here is the anatomy of that function in Python. You likely recall we have this function header, which included def, the name of the function, followed by inside the parentheses 0 or more. So it could be 0, but 0 or more parameters. And those were called formal parameters, as opposed to here we have on the right side, when we call the function, we have the actual parameters. So when we call the function, we send to it the actual value 7, the actual value 5. And where do we save those actual values 7 and 5? We save it inside the formal parameter num1 and num2. So the formal parameters, I like to call them placeholders, right? So over here, when we were running our code and we sent over the 7 right here, and we sent over the 5, those are actual values. That's the actual parameters we're sending over. Where does that 7 and 5, where do they get saved? The 7 gets saved up into this num1, and the 5 gets saved into this num2. These here are called formal parameters. They're placeholders. They're going to receive that 7. When you throw the 7 over and the 7 gets thrown to the function, that function catches the 7 and it puts it right there. But until then, we just put num1. So these are really placeholders where you're going to put the 7 and the 5. But until you put them there, and these are more officially known as formal parameters, whereas here we have the actual parameters. And then one more time, the entire thing here is the function header. The define, the name of the function, and then the list of 0 or more formal parameters. And here, once again, are the actual parameters. So actual parameters, those are the actual values. I just covered that extensively. You may have no parameters. You may have a half dozen or more parameters. You can have 0. Also remember, the word argument is synonymous with the word parameter. So arguments and parameters, they are synonyms. You can use those two words interchangeably within programming languages. Also, we have the function body. This is now inside the function. Do remember, of course, in Python, it ended with a colon. That method header, or the function header, ended with a colon. And then we have the function body inside. Finally, we have, on this particular example, a return value where we are returning the result. On the code that I showed you, I just returned num1 immediately. I could have said max equals num1, and here I could have said max equals num2, and then after the if-else block, I could have said return max. That's effectively how this is working. And so we have a return value. Since this is a function, this particular one is returning a value, so we have to say return result. Not all functions have a return value. Some functions merely print something. They may not actually return anything that was calculated. That's something to be aware of. Once again, here's the Python code. Reason I want to show you the Python code again, because the next slide is a Java code, which is going to be already larger because it's going to have the class, right? Public class, whatever the name of the class is. It's going to have curly brackets, so that's going to make it a little bit longer. It might be a half a dozen more lines of code, but it should feel pretty similar. So hopefully we're already in a safe comfort zone because Python functions are something we should know. Let's check out the next slide. So what do we have? I want to go back and forth. Let's look at the main first of all. So here's the main in Python. We have where we're reading in the A and the B, enter an integer. I love how you can do that, where you can prompt the user within the input function. That's awesome. So we have 2 lines, lines 8 and 9 to do that. Well, over here in Java, first of all, to read from the user, as you know, we need a scanner. And now we have 4 lines. We have to prompt the user on one line, and on the next line we scan. Of course, we have to have the data type. But all of these lines, lines 14 to 19, that's the same as lines 8 and 9. It's longer for those sets of lines in Java. But now look, here in Python, lines 12 and 13, in Java, 22 and 23. Notice in Python, we have the max number equals, and on the right side of that assignment, we're calling the max function. Same thing in Java, we have the max number equals on the right side, we're calling this max method, right? That's a method. And the only difference is the data type, and of course, camel case should be used since this is Java and that's the Java style guide. So let's go look at that max method in Java and compare it to here, the max function of Python. In Python, we're receiving 2 parameters. In Java, we're receiving 2 parameters. What's the difference? Data type. Here, we don't have to mention the data type. Java, you have to specify. We have 2 parameters. This first one is an integer. The second one is an integer. Now let's look at the body before we look at the rest of the method header. Let's look at the actual body of the method and compare it to the body of the function. We simply say if num1 is greater than num2, return num1. If num1 greater than num2, return num1. Else colon, return num2. Else curly bracket, return num2. The body's identical. That's exciting. So what's left? Well, the name of the method is the same as the name of the function. And what's left, what's different here? There's no define. Instead, we have public static. These are modifiers. We're going to talk about that, but that's going to be in several weeks. We'll talk about what is public, what is static, and their importance. Suffice it to say, for now, all of our functions will have, or all of our methods will have public and static. So the only thing we didn't discuss is this right here. And what is this? Why do we put int right here? Like this int makes sense. That's for num1. This int makes sense. That's for num2. What is this int right here? That is the return type. Because data types are important, we have to specify what is the type of data that's being returned. And since this method is returning data, we have to specify, are we returning a string? Are we returning a double? Maybe a char, maybe something else. In this case, we are returning a primitive int. So we have to specify that we are returning that int. So that's more of the bird's eye view. So now let's look at the anatomy of a Java method. So here's this same exact method, and on the right side, we are invoking it. Now I say it's the same method. The only difference is, once again, is like we have here in Python where I could have coded it this way. I'll show you the code in Java. You know what? I don't have it open in Java, I don't believe. Let me go back to NetBeans and let's see. Yeah, I don't have this one open, so that's fine. But in the same way that in Python, I could have coded it like this, right? Where I made the max variable and then I returned max instead of just returning num1 or returning num2. That's what I'm ultimately showing here in the slide to show you something a little bit different. So we've seen this solution where I return just num1 or return num2. Here, I'm declaring an int variable result. I'm saving the maximum value into result, and then I'm returning result. So here's the method, and here is where we invoke the method on the right. And let's break this down and look at the anatomy of a method. That's a lot. We're going to do this step by step. This is the method header. What does the method header have? It has that public and static modifiers. It has a return type, int. It has the name of the method. And then, like Python, it has 0 or more parameters. But you have to mention their data type. You must specify their data type. That is the entire method header. The name of the method, the 0 or more parameters that are separated by commas within parentheses, the return type, and then before that, the public and static modifiers, which we'll talk about their value and purpose later. That is the entire method header. We have to have a return type, as has been mentioned. You have to state what is the type of data that's being returned. Not all methods have a return type, as we've discussed. Some methods don't return anything. In Java, if a method does not return something, that is called a void method. And you have to specify void right where we're putting int. You would literally get rid of int and you would type void, indicating that to the compiler that this method in fact does not return anything. Formal parameters, we've already covered those. That's the list of parameters that is inside the parentheses of the method header. Those are the formal parameters. Those are the placeholders. The actual parameters are the actual values that we're going to send over to our method. That's identical. And we know that parameters and arguments are synonyms. So your parameter list can be empty. You may have no parameters. We've seen methods already in Java that have no parameters. How about math.random? When we call math.random, remember, there's no parameters. And what does that method do? It returns to you a number between 0 and 1, but not including 1. But just an example of a method that has no parameters. Method signature. This is a very important term. What is method signature? It's what I'm highlighting right here. Every method has a signature, and that signature includes the name of the method as well as its list of parameters. That's called the method signature. Very important, and we're going to be covering more of that in just a bit. The method body, here's the method body, nothing really new to discuss there. How do we call the method? We have to invoke it. We have to type into your program. How do we start a method? We have to call it, or we have to invoke it. And how do you normally call a method? Well, it usually depends on whether or not that method is returning a value. And this is the same in any language. So if a method is returning a value, normally we'll call that method in one of the following ways. Like the max method, since it's returning a value, you're usually going to want to save that value that it is returning, right? So you might say int space larger, you're declaring a new variable, equals, and we call max on the right side of that assignment. So when max returns for this maximum number, we can save it into the variable larger. That's because it's returning a value. Another example of returning a value using that same max method, maybe we want to print that returned value immediately. No problem. We can call that method max from within a print statement. But what about a void method? A method that does not actually return anything. If a method returns void, that call to the method is usually just a basic statement. It's not going to be inside a print statement. It's not going to be certainly on an assignment because it's not returning anything. There would be nothing to assign into a variable. So what's an example of a basic void method? Println is a method we've been using all semester. That method, we can send no parameters to it, in which case what happens? It just prints an empty space, an empty new line, or we can send many different parameters to it. Here's one example where we're sending a string parameter to that method. We're calling the method println, and we're sending over this string of text. What's going to happen? That method is going to print that string, as you know, to the output. Calling a method. When we call this method, program control leaves our main. Our main is effectively put on pause, like hitting a pause button. We leave the main working program, that's put on pause, and we go to the method. And now the method begins execution. And main is effectively waiting for the method that it called to finish. Imagine main calls method A. Method A calls method B. Well, when method B is running and executing, method A is waiting for method B to finish, and even method main is waiting for both A and B to finish. That's called program control, that the program control leaves the method that you were in, such as the main method, and the control now goes to the method that is currently being executed. And a called method will return control to the caller with these two circumstances. Either when its return statement is executed, at that point it will return control to the caller, and it's going to return whatever you're indicating should be returned. Or if it was a void method with nothing to return, program control gets returned to the caller when that final curly bracket is encountered. What follows is a detailed run through and animation of what I already showed you on this video, where I showed it in Thani, the detailed breakdown of what happens when we're calling this function. This is a detailed breakdown, but of showing what happens when we call this max method. We send over values, it gets returned, it gets printed. So if you want to go through and study that, pause the video and follow each step slowly. So here we want to write a new program, which is to sum many different numbers. Write a program that will sum 3 sets of numbers, and then it will display the sum of each set. We want to sum the integers from 1 to 10. We want to sum the integers from 20 to 37. And then we want to sum the integers from 35 to 49. We want to write one program that's going to do all of this. Pretty short. Let me show you a trash solution. So here's a trash solution, but let me just back up. Program, I shouldn't jump to the solution. I talk about problem solving phase, super important. But this program's really easy, so there's not much to talk about from a problem solving perspective. We basically need to make a sum variable. We need to initialize that to 0. We need to loop over from 1 up to 10, including 10, and add all of those values for sum. And then basically rinse and repeat. Do that again from 20 to 37. Do that again from 35 to 49. Here's a trash solution. And I want you to think about, why is this solution? Why am I calling it trash? I can imagine someone might shout out, because it's in Java. It's not in Python. I can agree with you to a certain extent. There's things that Java's better at and Python better at. But why is this a trash solution? I would argue it's not a very good solution, and I don't mind calling it trash because I coded it. So it's a trash solution. Why? Pause and think about that. I would argue why is because we are effectively repeating the exact same code 3 times. Here's the first set. We declared into variable sum. We set it to 0. We did a for loop. In that for loop, we added all those values to I, and then we printed the result. And then guess what? We simply did the exact same thing here, and once again here. We are repeating that exact same 4 lines of code 3 different times. That's horrible. And this is when we should be immediately realizing, red flags should be going off, that this should be an indicator that we should use methods. Hopefully we recall, what is the main purpose of functions? It's a great question. What's the main purpose of functions? There's a lot of benefits, right, to functions, but what is the main purpose? The main purpose is reuse. It's a lesson in being green, recycling our code. Make that code one time and then reuse it many different times. This is the sole purpose or the main purpose of functions. So once again, I observe that each of those sets of code is doing the same thing. That's horrible. Wouldn't it be better if, in fact, we could write some common code and then simply reuse that common code when needed? As we know, this is the idea of functions. This is therefore certainly the idea of methods as well. So here's a solution. And look how clean that is compared to the previous solution right here, where I did the exact same thing 3 times. Instead, now what I've done is I made a method. Let's look at this method. This method, we send over 2 parameters, a start as well as an end. I declared a sum. Now, I didn't have to space this out like this. I could have made it tighter. I could have gotten rid of the curly brackets, right? But I wanted it to be very clear. I declared a sum. I initialized it to 0. And in the for loop, I loop from start all the way until less than or equal to end, because we wanted to include that last value. And I merely add I to the sum. And now I return sum, which is why this has to have a return data type of int. And now when we look at our main, I simply have 3 print statements. The sum from 1 to 10 is %d. And I'm sending over, and when I put the %d, that's a placeholder. What needs to go there? Something after the comma. Well, when we look at what's after the comma, I'm calling some numbers 110. I'm sending the 1 up to start. I'm sending the 10 to the end. This particular method, it's going to sum those values from 1 to 10, and then it's going to return the answer, which is, I believe, 55, and that will then print. And we do it again for the second printf statement and for the third formatted printing statement. So some cautions, and then we're going to go through some programs. We have like 2 or 3 more to code up. A return statement is required for a value returning method. Consider the following. Here's this method over here, public static int sign. What is this method doing? It's simply checking this given parameter in, and if it's greater than 0, it's returning 1. If n is 0, we're returning 0. If this parameter n is less than 0, we are returning -1. Basically trying to determine, is it positive, is it 0, is it negative? So if it's positive, return 1. If it's 0, we return 0. Else, if it's less than 0, we return -1. This code is perfect logically, 100%. But we will get an error if we try to compile this code. We can't even run the code. We will get an error. I want you to I want you to reflect on why. Why would we get an error? So pause and think with me for a moment on what would possibly be causing an error right here on this code. And what's going on is that Java sees this return type, int. And in fact, I'm going to use a new term here. When we see this method header, this is a contract. A contract stating that anyone who uses this method, we expect you to send over a single parameter as an integer. And the method contract is guaranteeing that if you do that, the method's going to guarantee that they will return to you an integer. That's the purpose of this header. It's a contract. Imagine that I just tell you, hey, I got a method, and you don't know what's in the method. It's a black box is a term we use in computer science. I'm showing you a method header. I don't tell you what's inside the method, but I tell you the method receives 4 parameters, a string, 2 doubles, and an int. And I tell you the method, through the power of magic, it's going to do X, Y, Z, and it's going to return to you some double. You don't need to know what goes inside the method, what actually occurs in the method. What is important for you from a customer's perspective is you know what you need to send the method, and you know what the method returns. That's a contract. Well, so this is a contract, and Java's expecting that if it's saying we're going to return an integer, well, dang it, it better return an int. Java wants to make sure that it doesn't understand the logic here. When Java tries to look at this, it doesn't know that we're checking for positive, for 0, or for negative. It doesn't know that. It just knows that we have to return an integer. And it's going to give an error because Java sees that there may be the possibility that you're not covering all of your bases. And if this possibility exists, Java will give a compile error. Now you might be thinking, what do you mean? What possibility? What are we talking about? N is either positive or 0 or negative. Have you lost your mind? There's no other possibility. And that's right. There is no other possibility. It's perfect logically. But Java doesn't have that logic. Java doesn't know that. What Java sees is if something is true, return 1. Else if something is true, return 0. Else if something is true, return -1. Java's saying that, hey, what if none of those things are true? You need to have an else right here. And you're thinking, no, Java, but I promise you, one of those things is true. Either n is positive, either n is 0. The only third possibility is it's negative. We know that. Java doesn't know that. So Java says, look, all I see is you got if, else if, and you're listing 3 Boolean expressions, but Java's thinking, what if all of those are false? You would never have returned. You would never have returned anything. And once more, we're like, but damn it, Java, I returned, I promise you. Java doesn't know that. So Java says, if they're all false, you would never have returned. And this contract, this guaranteed contract that where Java says, I need to return an int, it would be broken. And so Java is concerned that you're not putting an else right here and ending it with an else. That's really the fix. The fix is super easy. You need to make this else if n is less than 0, you need to make it into an else. And that will address that concern, and this will now compile just fine. Because in fact, there are only 3 cases. Return 1 if it's greater than 1, 0 if it's 0. Otherwise, there's only one final thing, and so logically it really should be inside an else anyway. Because by putting an else if, we're indicating and suggesting that there might be a 4th possibility, which we know there's not, but that's what Java would be expecting. So that's very important to make sure inside your methods, or same thing in Python, inside your functions, you want to always, if you have an if block, you want to end with that else when you're trying to return something. So here we have a simple program, super easy. Print letter grade. Write a program that asks the user for a final score from 0 to 100, and then simply calls a method print letter grade that will print the associated letter grade for that score. So the problem solving phase, we need to have a main. This main method is going to ask the user for a score. No need to validate the score. Let's just assume they enter correct data. Once the score is read by the scanner, we're going to call the print letter grade method that will print the associated letter grade with that score. And yes, a fair assumption, 90 to 100 is an A, 80 to 89 or less than 90 is a B, and so on, your traditional scoring. So here is this print letter grade method. What parameters does it expect to receive? Well, it needs to receive the score, which let's say it's going to be an integer that we allow the user to enter. So we need to have a formal parameter, which is an integer called score. And what is the data type that is going to be returned? On this example, since we're merely printing the letter grade, it's void. We're not going to return anything. Here's the code. Look at the main. We simply have a scanner. We ask the user for their score, and we scan their score with next int. We save it to score, and then we call the method print letter grade, and we send the actual parameter score. Now that actual parameter, let's say the user entered 83. That actual parameter 83, it's going to come up here, and it's going to get saved into the formal parameter, this placeholder score. So now imagine 83 is here, and we can just go check it. If score is greater or equal to 90, nope, we're not going to print A. Else, if score is greater or equal to 80, 83 is greater or equal to 80, we're going to print letter grade colon is B. This entire set of statements, this entire if-else block is one block. You know that as soon as one of those is true, we're done with the if-else block, and then the program finishes. That is a void method. Notice it's void here because we're not returning anything at all. Pretty straightforward program. Read a score, make the method, call the method, send over the actual parameter, save it in the formal parameter, this placeholder, and then run this if, else if block, and then match with the appropriate score, and then print the letter grade. Pretty straightforward. Compare that to this one, which is instead of called print letter grade, it's called get letter grade. This time we want to get the letter grade from the method and have it return a primitive char value and return that letter grade to the user or to the calling method, which is main, to then be used within main. So now this get letter grade method right here, it has still one parameter, the score it's expecting to receive, but now the return type is char because we're not printing. The method's no longer going to print. It's not called print letter grade. We're not printing inside this method. Instead, we're merely going to return the A or the B or the C or the D or the F, and then inside main we're going to print. The whole purpose is just to show you a void method and then a very similar method, but no longer void, but instead this won't say void, it'll say char, and instead of printing, we'll just have here return A. So let's look at that code. So here, if the score, well, that's the previous code, sorry, and here's the code next to it, the change, so we can see them side by side. So the difference is instead of void, we have char. Instead of printing, we're saying return A. Instead of printing, return B, or return C, or return D, or instead of printing the letter grade as F, return F. All of the first three lines are the same, but now instead of just calling the function over here, print letter grade, and we send over the score, and we print within the, I said call the function, and we print within the method, now over here in Java, on this new program, where we want to get letter grade that I apparently misspelled. I call it Gent letter grade, which is fantastic. We call this method get letter grade. Now, notice we have a print statement, and I'm printing letter grade, colon, space, %C for a character. And we're using formatted printing. And what am I going to put here inside this %C? I'm going to put the result of calling this function. Pretty straightforward. Two methods. See, even me going back and forth, I'd be saying methods all the time, but I wanted to go back and forth between Python and Java, and I'm getting caught up. It's like method, Python, method, Java, no. And I'm saying the wrong thing, which is normal. For us, we can almost pretend they are synonyms, although they are not, and we're going to talk about those nuances. But for now, as I said, a Java, wow, I was about to say a Java function. A Java method synonymous for our purposes with a Python function. One more. Distance conversion, we're going to code this one up live. I have not coded this. Write a complete menu-driven program that allows the user to convert from both miles to kilometers and from kilometers to miles. You should have 3 total methods: a main method, a miles to kilometers method that's only going to do a conversion. That's all it's going to do. And then it's going to return the result. You should have a kilometers to miles method that also only does the conversion and returns the result. And this should be our output on the next page. We show you 2 sets of output because that's the easiest way to understand the program. So here is one particular sample execution of the program. We print this menu. Notice I allowed the user to put invalid input, and I have to tell them it's invalid, try again, enter their choice again. That's fun. That's going to be inside a loop. But finally, if they enter a valid choice, which is just 1 or 2, if they entered 1, I then ask them to enter the number of miles. They entered 10, and I print what it's equal. I do say here, note that 1 mile is equal to 1.609 kilometers. Of course, we're going to need that. And here is one more execution of the program. The previous one I started with miles to kilometers. Here, we're now going in reverse order from kilometers to miles because they chose option 2. Enter the number of kilometers, 5. That is equal to 3.11 miles. So we need a while loop to keep iterating until at this main menu until they give us valid input. Once they enter a valid input for 1 or 2, we're going to scan the number of miles or kilometers, and we're then going to convert it by calling that respective method, and then we're going to return that result and print it. So let's code this. This is going to be fun. File, new project. Next, let's call this what? Distance conversion. There we go. Distance conversion. Next. And part of me hopes, I enjoy making mistakes, so if I make a mistake, you get to watch me. I'm going to zoom way in for you. If I make a mistake, you can watch me fix that mistake. I need a scanner. I need to import this scanner, and I could just type it. I'm a fast typer, but I want you to see the process. We import. All right, after making the scanner, let's go ahead and make the methods first. I want to make 2 methods. What are they called? Miles to kilometers. Let's do that one. Public, static. And this is going to be something here. I'll put something. Miles to kilometers, kilometers. And I need to send over miles, right? Because I'm converting miles to kilometers. And since the conversion factor is 1.609, even if I send over just 1 mile, the result, 1 times 1.609, that's going to be a double, right? So the return type is going to be a double. And I can really just do this in one line. Return miles times 1.609. That's the method. Super easy. What about the next one? Public, static, double, kilometers, to miles, int, kilometers. What am I going to return here? You know what? Let's go over to the trusty tablet. So if we know that 1 mile, right, is equal to 1.609 kilometers. Now, what if I were to tell you that we have 2 miles? What are you going to do? You're going to multiply it times 1.609 kilometers. And so you're going to get some answer, which is like 3.2 kilometers. Well, basically I want you to realize, well, why do you multiply it times 1.609? Because this right here is effectively equal to 1, right? If we tell you that 1 mile is 1.609 kilometers, that's like multiplying times 1. So we studied this maybe in algebra in high school. I have 2 miles, and I want to multiply times, if I multiply it times 1, I've done nothing. I haven't done anything against the rules of math. So what am I going to multiply this by? Either I'm going to multiply it by 1 mile over 1.609 kilometers, which doesn't help me because this kilometers right here, it won't cancel with that miles, right? So you're probably like getting memories now. It's like, oh no, yeah, I did this in algebra. So what we're going to multiply here is we're going to flip these two, right? And we're going to multiply this. We're going to put the miles at the bottom, 1 mile. And here up top, 1.609 kilometers. Why? Because this cancels with this, and we're left with 2 times 1.609, which is what we said we wanted in the first place, right? That's how we got that. Like how we came up with this, right here we have 2, sorry, you can't see the code. How we came up with this over here, miles times 1.609, is by having thought of all of this already. So now the question, though, is what if you have 5 kilometers and you want to convert that to miles? How do you do that? You're going to multiply that times a version of this where the kilometers is going to be in the denominator. So the kilometers, because you're going to want this kilometer up here to cancel with a kilometer down here. So in which case, we don't even need to flip this because the kilometer is already in the denominator. So I'm going to multiply this 5 kilometers by 1 mile over 1.609 kilometers. And the kilometer cancels with the kilometer, and we're left with what? We're left with 5 divided by 1.609 miles. So long story short, if you have kilometers and you want to get miles, what do? What you do is you simply divide by 1.609. So if you have kilometers and you want to get miles, we divide by 1.609. So there's our 2 methods. Super easy, just a basic return statement inside each one. What does our main have to do? Let's come back to here. Oh, I wish I could copy paste this. So I want to type this as is, though. I want to make it look nice. So, and you know what? Let's even do one other thing. Yeah, let's go. Let's do a main menu. Public, static. Put a, not a wish me luck. Let's do a let's go. Let's go main menu. Public, static, void. Main menu. And what is our main menu going to be? It's going to be all of this. I want to go back and forth between these two. The main menu is going to be this. Print. And what is it? 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5 space distance conversion. 1, 2, 3, 4, 5. What comes next? Kilometers to miles. I need to print that. Kilometers to miles. Then no, miles to kilometers. So miles to capitalized. I want it to be identical. And here we have kilometers to miles. Cool. And what comes next here? Enter your choice, 1 or 2. Enter your choice, parentheses, 1 or 2, colon, space. And notice that the user's entering their information on the exact same line, which means we want to use a print statement, not a print line. So this is the main menu. So now this is just a void method. I just made that into a method. So now I can just call main menu. That'll print the menu. Cool. What has to happen now? You know what? I see that since we're going to be entering your choice, we'll be typing that again if they get it wrong. I'm tempted. Anyway, so what has to happen now is we need to have a while true. I'll get back to the printing in a moment. We need to get a while true. Inside this while true, we need to scan the user's choice. And we need to scan it as not an integer, even though we hope they enter a 1 or a 2, but we allow them to enter even bad data. So I'm going to just call this string choice. And I need to scan their choice. I'm just going to use next line. Choice equals n.next line. We have scanned their choice. Now, after we scan their choice, we need to check if it's a 1 or if it's equal to 2. So I'm going to say if choice.equals a 1 or choice.equals a 2. I don't like doing it that way. I could have done it differently. So if choice is a 1 or a 2, great, I need to do something. So you know what? I'm going to just do it one at a time, actually. So if choice equals a 1, what do I need to do? I need to enter, then I need to ask them to enter the number of miles. So here I'm going to save 2 new variables, int miles and kilometers. So if choice is 1, we're going to print enter the number of miles, enter the number of miles, and that is a print statement, not a print line. And we're going to scan those miles. And now we're going to scan it using next int. So miles equals n.next int. And then we're going to call the method, and we're going to get the result. So here, the result, I'm just going to use formatted printing. That is equal to blank kilometers. So check this out. We've scanned miles. So now call the method within the formatted print statement. And so here's the formatted print statement. And I'm going to print that is equal to %.2f. We want 2 decimals, 2 digits after the decimal. Kilometers. Kilometers. Period. Did we put a period? There was no period. But there should be a period. It's a sentence. So I'll leave it as a period. All right, let me zoom out some so we can see this whole thing. Because now I need to put a comma, and I need to actually call that method. And what is the name of the method? We're going from miles to kilometers. So I'm really just going to call this method miles to kilometers. And if I just type in m, because I have code completion on, it does that. And look, it automatically populates for me. And it automatically populates. What does it not like? I did print ln instead of printf. So that's equal to %.2f kilometers, miles to kilometers. I'm sending over miles. The result is going to then come back from the function and print right there. Cool. Guess what? Assuming that works, smart of me would be to check this. You know what? Let's check it. That would be smart. Let's enter 1, enter the number of miles. Let's say it's going to be 2 miles. 3.22 kilometers. That looks about right. So I'm going to hit stop. So now let's paste this, and this is going to be else if the choice equals 2. Enter the number of kilometers this time. And we're going to scan not miles, but scan kilometers. And now we're going to say that is equal to blank miles. And this is going to be, let's delete all of this, and this is going to be here, kilometers, 2 miles, and notice it automatically even realized that I probably wanted to use that variable as the parameter, as the actual parameter, which I did. So if the choice is 1, do that. If the choice is do that, 2, do that. Else, if the choice is anything else, what do we need to print? Invalid choice, please try again. So I need to print invalid choice. Where's it at? Invalid choice, period. Please try again, period. And I go directly to the next line. But I do notice that there is a blank line above it. So I'm going to put a blank line with just by putting a \n. And then we're done. And notice, the only reason for this loop is in case they put bad input, right? If they put bad input, we want to keep asking them over and over and over, right? If they put in something here, invalid, try again. 6, try again. 0. Oh, we need to print. After saying please try again, we need to print enter your choice again. So let's fix that. Let me actually stop and fix that. So here, we want to print enter your choice. Enter your choice. And this is going to be 1, 1, or 2, colon, space. And now we need to scan that choice again. And here's where code design is important, because you're like, oh, but I already scanned that choice up there. So what can you do instead? What I'm thinking is, I'm going to keep this as a while true. You can also do a do while. But we've done, what I really want to do is I want to take this line of code right here, and I want to erase it from here, and I want to include this up here within my while true, and I'm going to remove that from the main menu print. And we're only using the main menu once. It's not in the loop, so there's no need to have that method, but why not? Okay, so now while true, enter your choice, scan it. If it's 1, do that conversion. If it's 2, do this conversion. Else, if it's anything else, invalid choice, please try again. So now let me hit stop and run this one. And enter the choice, we put garbage. Let's put 5, let's put 0, cool, let's put 1. And when we enter the number of miles, let's say 2 miles, and notice when I put 1, and then we have enter the number of miles, here we had a space before then, so let's fix that. Enter the number of miles, we need a \n, and here we need a \n. Let's run this again. Every time you see an error, just fix it right then and run it again. No harm, no foul. Put bad input, that works. Put 1, that works. We have a good space here. Enter the number of miles, 2 miles. This is equal to this many kilometers. And look what happens. The program keeps running because once they put in a valid choice and they do one conversion, the program, on this example, it ends. So what we really should have done is included right here a break, and then right here a break. We break if they do a valid choice. We do the conversion, and then we break. So finally, let's run each of these. Enter your choice, 1, number of miles, let's say 3 miles. It's that many kilometers. Cool, program's over. We put some bad input, put some more bad input, no problem. Let's do choice 2. Enter the number of kilometers, 5 kilometers, 3.11 miles, and the program ends. We still got the let's go. I left that there on purpose. That wasn't too bad. I hope it wasn't too bad. I want to say let's go again, because guess what? When we come back to here, that was the last thing. Super excited. As always, you got any questions, leave comments, reach out. It's been fun. Take care.